Hi, I'm Chris Guzikowski. I'm here at Software Architecture in London, and I'm joined today by Pepijn Kamp from Software Improvement Group. Welcome, Pepijn.
Thank you very much.
Can you tell me a little bit about SIG, Software Improvement Group, and what it is you do there?
Absolutely. So I work for the Software Improvement Group as a technical consultant. The Software Improvement Group is a company that helps clients with software quality assurance and aims to give advice to control and manage the risks involved in all kinds of quality aspects of software engineering. For example, maintainability, but also the resilience and security of software systems. So as I told, I'm a technical consultant, so in my daily work I analyze software systems for clients, and of course software architecture is an important aspect also in that work. Yeah.
So can you tell me a little bit about what role software architecture plays in your day-to-day work?
Yeah, what we see these days is that software architecture is actually a key differentiator in order to be competitive in this market these days. Mm-hmm. So our clients, they have a lot of issues that they struggle with on a daily basis. As a business owner, you might wonder if the architecture that was chosen by your team, if it's actually a good fit for the goals that you have as an organization. So we try to answer these kinds of business questions in the analysis that we do for our clients.
Mm-hmm. Yeah. And is that analysis, I'm cheating a little bit here because we talked earlier,
yeah.
But a lot of that analysis is data-driven, yes?
Yeah, so it's very important for us to base our advice on objective facts.
Going into the code, really rolling up your sleeves and seeing what's happening.
Exactly, but also performing sort of scientific measurements. So what we do is we perform measurements, and we do this on a very large set of systems. Over time, SIG, Software Improvement Group, already exists for over 17 years. And during the lifespan of the company, we have seen a lot of source code. And currently we have over 10 billion lines of source code in our data warehouse.
It's a billion.
Yeah, yeah.
That's a lot.
That's a lot,
sure.
Yeah. So what we do is we compare your system to this large set of benchmark data to reason about certain quality perspectives and see which areas can be improved or which areas are already on par.
Okay.
Yeah.
So when it comes to software architecture, what problems do you most frequently encounter when you're with clients?
Yeah.
Are there trends that you're seeing there?
Yeah, absolutely. So what we see a lot is, of course, there's the desired architecture as it was designed once, maybe by an architect. Mm-hmm. And of course, teams start implementing this architecture in the source code. But because of the missing link between the source code and what the architect actually designed, we see that there's a discrepancy there.
Okay.
And so software tends not to be implemented according to the initial design, and these are things that we can derive from the source code. So we can look at the implementation and compare that to the planned architecture to find deviations in that area.
Interesting. Okay. And if you had a crystal ball here, if you're a wizard, what do you say? So we're hearing a lot this week about trends that, software architecture was very stable for a lot of years, and it was a rather, stable pursuit. Yeah. But now with the advent of microservices and serverless and cloud computing and the proliferation of data, where do you think we're going in this field? What do you think the future holds in terms of software architecture?
Yeah. So what you're saying is right. I also see that in my daily work. The landscape shifted radically in the past couple of years. Mm-hmm. So what we see now these days is that developers sort of perceive this new microservice architecture as a silver bullet. So everybody tries to embrace this new architecture style. And what we try to do as Software Improvement Group is to look at the facts, to understand the trade-offs. Of course, a microservice architecture might be suitable for your particular problem, but what are the costs that are involved, and what goals are you actually trying to achieve with this architecture, and is then the microservice architecture the best fit?
So you're able to show them that it's not necessarily a rosy picture. There's traps and pitfalls potentially along the way.
Exactly, yeah.
Right, and just hopping on the new trend might not be the best course of action for them.
Yeah, and that is one of the biggest traps, I would say, of the current trends that we see in software architecture. So it's sort of a fashion to use new styles, to try out new sorts of technologies and architecture paradigms. But you always need to take that step back to look at what problem are we actually trying to solve and what is then the best fit for that problem. But what I think is going to be a very pressing issue in the coming years is the degree to which clients are able to manage their usage of open source libraries and frameworks. What we see is that these frameworks are, of course, very popular, but also for hackers. So in the cybersecurity space, we see that there are known vulnerabilities in those components, and clients need to act upon that. And what we see is that currently many clients have actually no ideas which libraries they are actually using, which versions they are using, if there are known vulnerabilities in those libraries. And we think that in the coming years this will be an important topic, and we need to advise our clients to get control about their usage of open source.
So the late Watts Humphrey, who a lot of people consider the father of software architecture, once said that every business is a software business. Are you seeing that in your work? I mean, if that's the case, does that mean that architecture is becoming more and more important to not just technological success, but overall organizational health?
Yeah, there's this nice saying that software is currently eating the world. I think the numbers say that on average $120 billion is wasted every year on software systems that are of poor maintainability, so that are hard to change. And having a good architecture that is also maintainable is a very important differentiator in the current time era.
That's great. Well, it's going to be interesting. These are heady times, and I know that the agenda at each of our subsequent meetings changes, and we hope you're there along the way with us. So thanks very much for taking time today. I enjoyed our chat.
Thank you very much.